In section 11.3, we're learning about another one of the conic sections, the parabola. And the definition of a parabola is going to be a parabola with a focus point P and a directrix, which is line L, is the set of all points X such that the distance from X to P is equal to the distance from X to L. So here we have an example of a parabola, and let's say that X is going to be any point on that parabola, and I choose this green point here. The definition is saying that if we calculate the distance from X to this line L, which is called our directrix, the shortest distance, of course, is going to create a right angle. And so that distance there in green is always going to be equal to this distance here in blue from that point X to the point P. So it's a point P and to line L. So those distances are always equal, and that is going to change, that distance is going to change as that point X moves along the parabola. So a couple of important things to remember. Your line L, that's going to be your directrix. Your point P is your focus. You have an axis of symmetry here, and then you of course have your vertex. And let's look at an animation of a parabola just to help you understand it a little bit. Here's a video that helps you understand. You can see that as the point X is changing, that those two distances, those two blue distances, are still equal. Let's just watch that one more time. And X is the red point that's on the parabola. Okay, now we're going to work through a couple of examples, and in this first example we're going to show that the graph of the equation y squared minus 16x equals 0 is a parabola. We're going to draw its graph and then find and label its focus and the directrix. Well, first of all, we have a pretty good idea that this y squared minus 16x equals 0 is a parabola because it has a single quadratic term being the y squared here. Whereas with the ellipse and the hyperbola that we've looked at so far, it had two quadratic terms, the x squared and the y squared. So what we're going to do is try to isolate the quadratic term. When we do, we get y squared equals 16x. Now that we have that, we can think about, since the y is squared, we know that what's going to happen is that this parabola is going to open either left or right. Because we have a y squared term and not an x squared term. So what we're looking at is a parabola. It's going to look something like this. It's going to be on its side. And we're going to have a directrix. And the directrix is going to be the same distance from the vertex as the focus. So we're going to let that red point on the other side of the vertex be our focus. We need to find those two now that we have the equation. So remember, we talked about the equation being y squared is equal to 4p times x. So what we know is that 4p is equal to 16. And since 4p is equal to 16, then that tells me that p is equal to 4. And that p equal to 4 tells us how far from the vertex to the focus, and then, so that's 4, and then how far from the focus to the directrix, okay, here. So what do we know? We know that it has a vertex, and that vertex is 0, 0. If the vertex is 0, 0, and it's on its side, and this is the distance 4, then that makes our focus the point 4, 0. And then that makes the equation of our directrix here. Since we have a vertical line here, what's constant is our x. Our x is constant, and x moved back 4 from 0, so x is going to be negative 4. And there we have the graph. If you wanted to put the xy coordinate plane on it, the coordinate plane would be, there's your y-axis, and your x-axis would be here. So we have everything labeled. Okay, on our next example, we're going to use our calculator to graph a parabola. And just like in other examples that we've done, we are going to isolate the x squared, which that is already done, but we need to solve for y. So when we solve for y, we take the square root of both sides, and we end up with this, which is going to require me to use a y1 and a y2. In the y1, we're going to use positive or negative, it doesn't matter, and in the other, you use a negative. So we're going to graph both of those on the calculator and take a look at our graph. Okay. All right, so you can see in my y equals I have y1 is root 3x, and in y2 I have negative root 3x. And I'm going to do a zoom 6 and look at that graph. And I do have a parabola on its side. Remember, the y term was a quadratic term, so again, it's on its side. And there we have our parabola. And in example 3, we're going to find the focus, the directrix, and the equation of the parabola that passes through the point root 25, has a vertex 0, 0, and has a focus on the y-axis. We're going to sketch the graph of the parabola and label the focus and the directrix. Okay, so first of all, I'm going to start out with that information that says that the focus is on the y-axis, and then also that the vertex is going to be at 0, 0. Okay, so if this is our xy, then what we have is a center here at the origin and a focus that is somewhere on that y-axis. Or I'm sorry, this is the vertex here at the origin. And since that's the case, because the focus is on the y-axis, we know that this equation is going to take the form x squared is equal to 4py. Okay, because it means, with it being on the y-axis, it means that the parabola is either going to open up or down, and that means that our x term is our quadratic term. All right, so we have that information. The x squared is equal to 4py. And we also know that the point root 25 is on our graph. So that would be an example of an xy coordinate that's on our graph, which means that we can now take those values, that x coordinate and that y coordinate, plug it in, and find the value of p. So I'm going to end up with root 20 squared is equal to 4 times p times my y, which is going to give me 20 is equal to 20p, and that means that p is equal to 1. So if that's the case, then I'm going to have the equation x squared is equal to 4y. That's my equation. And now I can use that to go ahead and graph. Since the p is positive, then my focus is going to be up 1 unit. So our focus is here, and it's going to be the point 0, 1. And then our directrix is going to be that same distance from our vertex, and it is a line. And since it's a horizontal line, what we have is a constant value for our y. So this is going to have the equation y equals negative 1. All right, now with that, we can, our graph of a parabola is going to open up. So it's going to look something like this. And we have one last example, and we're going to save this example for class.